All right, so back to this one. First, we have to check whether the sum of 3 and 5 is greater than 9, which it isn't. That means this is not a triangle. That means we can't do any of this stuff. It's just not even a triangle, so it can't be acute, obtuse, or right. All right, let's move on to special right triangles. I cannot stress enough the importance of this. This is a section, or it's a topic rather, that you can cover this, 8 or 9 times, and still it'll be useful to go over it one more time. This topic, special right triangles, will stay with you throughout your high school career. It'll pop up in the most unexpected places. It's just like factoring. When you least expect it, it's right there. Or like the quadratic formula. When you least expect it, it's right there. And so is this. So it is really, really important that you understand, really comprehend what the section is about. And if you don't, come see me. Come see me like right away so we can take care of it, because this isn't something that, you can just, do away with. And it's going to be on your test. It's going to be on your quizzes. It's going to be everywhere. You're not going to be able to shake this. Okay, so let's talk about this then. We've been talking about right triangles. And what classifies a right triangle is that, what? It's got a what? It's got a 90-degree angle. So it's got a 90-degree angle, and the other two angles, what do we know about the other two angles, the two acute angles? All we know is that they're what? They add up to 90. They're complementary, but they could be any combination, okay? It could be 30 and 60. It could be 20 and 70. It could be 10 and 80, right? So, but there are two special cases. And the one special case is this. It's called a 45-45-90 triangle. So suppose you take a square. What do we know about a square? It has 4 right angles. And suppose you take a square and you cut a square in half diagonally. Okay? When you do that, now this angle was 90 degrees here. Okay? It gets cut into 2 equal angles, 45. So that's 45, this one is 45, and that one is 45. And now what I want to do is I want to find the measure of that diagonal. When I know that this angle is 90 degrees, so why don't I apply the Pythagorean theorem to find the measure of the diagonal? C. All right? So Pythagorean theorem says a squared plus b squared is equal to c squared. What's a and b here? 1 and 1, right? It's a square. All sides are the same. So if this is 1, so is that. So I have that 1 squared plus 1 squared is equal to c squared. Well, this is 2 equal to c squared. And when I take a square root of both sides, what does c equal? Square root of 2. Okay? So here c is equal to the square root of 2. Well, okay, so that's fine. Okay, that was really like the most simple case because the sides were equal to 1. You know what if you have a square where the sides aren't equal to 1? Let's say you have a square where the sides are equal to 3. Okay, and if you cut that into 2 diagonally, then here is c again, and the sides are each 3. Okay, and how big are the angles here? 45, 45. Remember, a square is also a rhombus. And remember, in a rhombus, each diagonal cuts opposite angles into two, right? Okay. So let's do the Pythagorean theorem for this one. You have 3 squared plus 3 squared is equal to c squared. 9 plus 9, that's 18, equal to c squared. So c is equal to root 18, but we really have to simplify that, and it's how much? 3 radical 2. Do you notice a pattern? Root 2. Whatever the sides, whatever the legs are, the hypotenuse is the leg times root 2. And this is one of the big theorems about 45, 45, 90 triangles. Okay? So this is a 45, 45, 90 because those are the angles, 45, 45, 90. And when you do have a 45, 45, 90, it never fails. Okay? Now, let me ask you another question. If two angles are the same, okay, what type of triangle is it? Isosceles. That means, what do we know about the sides opposite to them? They must also be congruent. So you see how like everything you know about life now is like being tied together? So if the two angles are the same, it means the two legs are the same. And what's more is that the hypotenuse is always the leg times what? Root 2. Yes. So when you're walking down the street and if on a billboard you see a 45, 45, 90 triangle, you just know the two legs are the same and the hypotenuse is the leg times root 2. Okay? That is our favorite theorem. You may have. So the length of the hypotenuse is root 2 times the length of a leg. And, you know, we like to write it like this. Hypotenuse is root 2 times leg. So what does that mean about the leg? How big is the leg? Going with that theorem, it's the hypotenuse divided by root 2. Okay, and then you would have to rationalize, of course. Okay? All right, so let's look at this special right triangle. Okay? Or this right triangle, rather. Well, we know that these two sides are congruent. What does that mean about x? It's 5. Now, if the two legs are congruent, what does that mean? Can you get the lights? If the two legs are congruent, what does that mean about these two angles here? They're congruent, and the only thing that they could equal to is 45 and 45. So now I have here. So now I have that that's 5 and that's 5. And how big is the hypotenuse? 5 root 2. All right? And it's always, you know, a radical 2. N radical 2. Okay? All right, so let's take a look at this next one. We have 45 degrees here and here. So we need to find x and y. Well, we know that if it's 45, 45, 90, then how big is each leg? Or what do we know about the legs? The legs are congruent to each other, okay? So we said that the hypotenuse is equal to root 2 times the leg. So that means 20 is equal to root 2 times x. And what do we know about, what can we do now? Divide by root 2 on both sides. So now, x is equal to 20 over root 2. But what do we do to that? Right? Rationalize. So x is how big? 20 root 2 over 2, which is really 10 root 2. So x is 10 root 2, and y is also 10 root 2, because they're equal to each other. Okay? And if you wanted to check, so this is 10 root 2, right? This is the leg, and that's the hypotenuse. So let's check. The leg times root 2, right? The leg times root 2, that's what? 10 times 2, 20. Okay? You could do like Pythagorean as well, and so on and so forth. All right, so that's the first type of special right triangle. It's when you take a square and you cut it in half diagonally. Now, what if you take an equilateral triangle? Because those are like one of our favorite triangles. And let's cut an equilateral triangle in half. With the altitude. All right? So the altitude goes from where to where? It goes from the vertex to the opposite side, and it's perpendicular, right? So here's the altitude, and it's perpendicular. Okay? So when that happens, this angle was 60, right? Because what do you call it? It's equilateral, so this is equal to 60. That means how big is this angle? 30 degrees. Okay? And now, this side gets cut into two. Okay? So each one of these is how big? 1. And let's call that A, and this is C, right? Because that's the hypotenuse. Let's apply the Pythagorean theorem to this. A squared plus B squared equals C squared. 1 squared plus B squared is equal to 2 squared. Okay? So B squared is equal to 3. B is equal to root 3. All right, and that brings us to our other theorem, okay? When you have a 30, 60, 90 triangle, how many different sizes of angles do you have? You have 3 different sizes of angles. That means you have 3 different sizes of the sides. Okay? The hypotenuse is always the longest side. And then you have a short side and a medium side. Okay? So let's whoa. Okay? Look at this one. This is the hypotenuse. That's the longest side. Now you have 2 legs. You have the short leg and you have the long leg. Okay? So it just so happens the short leg, right? This is the short leg. It faces the smallest angle, 30 degrees. The long leg faces the 60 degree, and the hypotenuse faces the 90 degree, right? And remember, smaller angle always gets the smaller side. So 30 degrees gets the smallest side, 60 gets the medium side, and the 90 gets the hypotenuse, which is the longest side. Okay? Now what about their measures? The hypotenuse is always twice the shorter leg, and the longer leg is always root 3 times the shorter leg. All right? The way we say this in short is if the short leg is n, then the next one is n root 3 and 2 times n. Okay? So if the short leg was 5, how big would this be? The long leg. 5 root 3, and this would be 10. 2 times 5. Okay? All right, so let's do this one. All right, so here's your 30, 60, 90. Okay? The one facing the 30 is always the short leg. Right? Where is the long leg? That's the X. And what's Y then? The hypotenuse. All right? So now, we know that if the short leg is 10, then the other leg is how much? 10 root 3. And the hypotenuse is 20. Okay? So it's always n radical 3 to n. A radical 3 to a. X radical 3 to x. Okay? Look at this one. X is this entire thing. So let's just identify the triangle first that we can work with. This is a triangle that we can work with. All right? So of the 3 sides, which one is the 12? Is it the long leg, the short leg, or the hypotenuse? This is the long leg. Where's the short leg? It's half of x. This one is the short leg. And what's y? The hypotenuse. All right. We are given the long leg. Okay? How does that relate to the short leg? So always try to relate one of the sides to the short leg. Okay? So always relate a side to the short leg. So how does the 12 compare to the short leg? The long leg is equal to root 3 times the short leg. Okay? So now the long leg is 12. That's equal to root 3 times the short leg. Well, then how big is the short leg? 12 over radical 3 is the short leg. Okay? So how much is that? 12 radical 3 over 3. 4 radical 3. Okay? Right, so this isn't x yet. This is just the short leg. How much is x? X is 2 times 4 radical 3, 8 radical 3. And now how much is y? The hypotenuse is, how does that relate to the short leg? 2 times the short leg. And how much is the short leg? 8 radical 3. Wait, how could they be the same?
No, just x and y.
Oh, sorry.
Oh, because x is...
Okay. All right, so the next one says, the perimeter of an equilateral triangle is 18. Find the leg of the altitude of the triangle. Now, what comes next is super important. When it says to write the exact answer, what does that mean? Don't round. No decimals, just radicals. Okay? Because decimals are never the exact value of something. When you convert something to a decimal, you're rounding. Okay? So it's never the exact answer. Meaning, if it says write the exact answer, that means you have to leave in radical form. Okay. All right, so find the length of the altitude. So let's first draw the altitude. Now, this is an equilateral triangle. If it's an equilateral triangle, how big is each angle? How big is each angle? 60. So this is 60. Here, this is 90 because it was the altitude. That means that's 30 degrees. How big is each side if the perimeter is 18? 6. 6. And then how big is this side? 3. Okay? That much is 3. Okay, and now what we need to find is this x. So in the, as far as the sides of a triangle, what is x? Is it the short leg, the long leg, or the hypotenuse? X is the long leg, okay? Because it faces the 60, it's the long leg. That's how you know. So x is equal to the short leg times root 3. It's just 3 root 3. Okay, next. The diagonal of a square is 10 centimeters. So we draw the diagonal of a square. Now, if the problem has units, your answer must have units, otherwise points will be taken off. 10 centimeters, we need to find the perimeter of the square. To find the perimeter, first I have to find the side of the square, okay? Okay, so this is the side of the square, x. So what type of triangle do I have here? 45, 45, 90. That means if this is x, how big is this angle? Side, x. Right, yes. So, well, how does the hypotenuse relate to the leg in a 45, 45, 90? It's not 2 times the shorter one. There is no shorter and longer in this one. Now this is a 45, 45, 90. So it's x, x, x radical 2. Okay? So 10 is equal to x radical 2. That means I divide by radical 2, I divide by radical 2. 10 over radical 2 is equal to x. So x is equal to 10 radical 2 over 2. How much is x? 5 radical 2 over 2. Am I done? Now I need to do what? Now I need to find the perimeter. It's 5 radical 2, you're right. So the perimeter is 4x, which is 4 times 5 radical 2. So it's 20 radical 2. Centimeters. Okay? All right, the length of an altitude of an equilateral triangle is 5 root 2. So here's the altitude, 5 root 2. Okay? Find the length of each side of the triangle and then find the area. All right, so I'm going to label the horizontal one x and this one y. How big is the angle at the bottom here? This one. 60. How big is the angle on top? 30. Okay, so is y the long leg, the hypotenuse, or the short leg? That's the hypotenuse because it faces the 90. What about this one? Short leg. So this is the hypotenuse, and this is the short leg. That means this is the long leg. Okay? So now we know that the long leg is equal to the short leg times radical 3. Okay, so let's substitute what we have here. The long leg is 5 radical 2 is equal to x radical 3. What do I do now? divide by radical 3, divide by radical 3. So x is equal to 5 radical 2 over radical 3. Now what? Rationalize. So x is equal to 5 radical 6 over 3. Okay? So that's x. It says to find the length of each side. So how big is the entire side of the triangle? If x is 5 root 6 over 3, it's twice that, right? Because x is half of the side, right? So the side is 2 times x, meaning it's 10 radical 6 over 3. Okay? So that's the side, and then we also need to find the area. Okay, so how do we find the area? Half times base times height. Half, how much is the base? 10 radical 6 over 3. Right, and how much is the height? 5 radical 2. Okay? Cancel the 2 with the 10, gives us a 5, so the area is 25 radical 2 over 3.
How did you cancel the 2? Oh, the 10.
Right? Oh, but this is so much fun.
So what did you do with the radical 6?
Huh? Well, how much is y? 2 times x, which is what? And that's the same as the side, right? Because once you found one side, this is an equilateral triangle. All right, so this homework will be due Friday. Tuesday. Oh my, due Tuesday.
Where does the rad 6 from?
Yeah.
Wouldn't it be like 25?
That's what I was looking at. There is some stuff missing here. Yes, this is a radical 6. There is a radical 6 here. So it's 5 times 5, 25. Radical 2 times radical 6, meaning, yeah, so this is 25 radical 12 over 3, which means the radical 12 is 2 root 3, right? So it's 50 root 3 over 3. Oh my. All right.